Good afternoon, everyone. I'd like to welcome you to the Glass Recycling Coalition webinar for the public sector representatives called Making Glass Recycling Work in MRFs. My name is Marissa Segundo, and I'm joined listening in by Michael Timpain. We are both with Resource Recycling Systems, or RRS. We are proud to be the managing consultancy for the Glass Recycling Coalition since it began. It's our honor that so many of the representatives from state and local governments are joining us today in learning more about glass recycling challenges and solutions. I personally represented the public sector for 7 years, nearly 7 years, in a community that removed glass as their recycling coordinator. The community later added glass back, so I understand where many of you are coming from. Michael Timpain represented, is a nationally recognized single-stream MRF expert with more than 30 years in the industry. And we encourage you to reach out to us as a resource within the GRC, or the Glass Recycling Coalition, anytime with questions about glass recycling and the GRC. Today, we are very fortunate to have a great panel of experts, moderated by Susie Gordon, Waste Reduction and Recycling Program Manager in the Environmental Services Department for the City of Fort Collins, Colorado. She's a valued member of the GRC's Government Advisory Council, and she'll be introducing today's panelists, who are also GRC members, Rusty Angel from Machinex and Cal Tigchelaar from Resource Management Company. Before we start, I have a few brief technical details. Take a look at your control panel to the right. This allows you to change your audio settings, to interact with the RRS team that's helping to run this webinar. You may have noticed that you can hear us, but all the attendees are muted, so we can't hear you, but we want to hear from you. So using that same control panel, you'll see a little Q&A bubble. That'll give you the ability to chat with us, to send in either technical questions or questions for the presenter as we go through this presentation. We will hope to get to as many questions as we can at the end, so feel free and send them in throughout the presentation. Finally, there will be a recording available to you on our website by the end of the week. So let's start with a little bit of information about the Glass Recycling Coalition. This is a unique collaborative that began in April in a meeting in Washington, D.C. At that time, founding partner members, including the Glass Packaging Institute and beverage leaders like Diageo and New Belgium Brewing, gathered with nearly 24 members of the glass recycling chain to create a non-competitive coalition with the goal to make glass recycling work. The coalition currently includes more than 30 companies and organizations that represent glass manufacturers, haulers, processors, material recovery facilities, and brands that use glass packaging in their products. Also capital investors and end market users. The diverse membership makes this coalition unique because it is the first time that members across the glass recycling value chain have come together to find solutions around a single issue, making glass recycling work. Now we'll hear from our presenters about this today, but the market demand for quality recycled glass still remains strong. The glass container and fiberglass industries purchase about 3.2 million tons of recycled glass annually to supply more than 70 U.S. manufacturing plants. So how does that all tie into the Glass Recycling Coalition? As an organization, our focus is to pass on the collective expertise of our membership and in the industry in general to share best practices in glass recycling collections, processing, and ways to strengthen glass markets. Cooperatively, we can identify high-needs areas, high-needs communities throughout the U.S., share knowledge, and help to find customized solutions to increase and maintain quality glass recycling collection where that's possible. This fall, the Glass Recycling Coalition launched its website, glassrecycles.org. This is a great resource to find those best practices and case studies, other communities that are making glass recycling work, find market maps where glass recycling resources are available, and find more about this organization's initiative over the past 8 months. Our organizational structure is led by our launch committee, which includes representatives from GPI, New Belgium Breweries, Diageo, and OI to oversee our annual work initiatives. One of our major initiatives is to provide support to the public sector. It is essential to hear from the public sector, from local and state governments, to find out what their glass situation is and how we can best help. And as I mentioned earlier, the GRC has a government advisory council, and this is a great time to pass this presentation on to today's moderator, Susie Gordon, who can explain more about the Government Advisory Council and also how you can be involved as a glass champion.
Great, thank you very much, Marissa. Can you hear me okay?
Yes, you sound great.
Great. I'm so pleased to be participating in today's webinar. As Marissa mentioned, my name is Susie Gordon. I work for the City of Fort Collins in northern Colorado, and I'm part of this Government Advisory Council that was formed. There are about 5 of us that are trying to help work on this project and bring advice and input from local governments all the way up to state governments. And we're a non-voting group on the GRC, on the Glass Recycling Coalition, and really just here to try to help improve and maximize effective glass recycling. We provide input about glass recycling in our respective regions and the interactions that we are experiencing with our government officials. Among important advice areas, we're sharing best practices and innovations in glass recycling, everything from collection to processing to markets, and bringing attention to sort of the gap or problem areas in the glass recycling value chain that we observe. And then we're also providing some input on the tools that are being developed to help local governments. Since all of recycling is local, glass really needs a voice in the communities throughout the country. And so we rely on what we're calling glass champions to be advocates for glass recycling. And our coalition is really trying to make sure we can provide the tools and work directly with communities about making, in the interest of making glass recycling work wherever possible. So glass champions are helping to share best management practices, as I mentioned, and innovations, collection, processing, and markets. And we think that you might like to become engaged as a glass champion, and if so, would you please contact us, because we'd love to have you involved. So we invite you to become involved by communicating with us about your own local glass recycling outlook and tell us what you need and how we can help. Again, our aim today is to help increase knowledge about how glass behaves in processing and to help find processing solutions to help make it work. Before we start with our presenter, we'd love to get an idea of who is on this call. So we're going to show you a poll on your screen with a multiple choice question. Could you take a few minutes here, just a second, to complete the poll? We'll show the results on the screen in a couple minutes. This will give us an idea of who's in the audience, and that'll give us the, I think, ability to really focus our questions at the end of our presentations. I know you're going to really enjoy listening to the great presentations from our speakers today, and they're going to have some really, I think, this great opportunity to find out from them more after their presentations about specific questions you might have for your locality. So with that, I might go ahead and get started. We're going to wait for that results to come up on that poll. But let me go ahead and start by introducing our first speaker. And his name is Rusty Angel. Rusty is with a company called Machinex, and he's been selling industrial equipment since 1999. After nearly 10 years at Vicoplan selling large shredders for plastic, wood, tire, and textiles industries, he joined Machinex in September of 2011. and he handles the southeastern U.S. for this Canadian-based company. Machinex offers a variety of glass cleaning equipment, and so this has Rusty working with many MRFs, or material recovery facilities, to develop solutions for their glass. Machinex also has a strong relationship with UK's Crystalline Technologies. We'll be hearing more about that from Rusty. This is a company that develops solutions for MRF glass all over the world. So with that, I'm going to turn our presentation over to Rusty. Thank you very much for joining us today, Rusty.
Great, thank you for that. I appreciate it. Can you hear me okay? Marissa?
I can hear you just fine, Rusty.
Okay, very good, good. Well, yeah, we're very excited to be a part of this. We're excited to be members of the Glass Recycling Coalition. Just a little bit about Machinex for those of you who don't know who we are. As she was saying, you know, we sell sorting and separation equipment into a lot of different types of MRFs, anything from single stream, dual stream, commercial, mixed waste processing, and so as you can imagine, we're dealing with a lot of different MRFs all over the country. So we get to see a lot of different material compositions. Those compositions can change based on, you know, the resident population density, those kind of things. So we're getting to see this issue from a lot of different angles. The perspective that I kind of want to present on today is directly from the standpoint of the MRFs. Because of the fact that we're in so many MRFs, that's where we sell our equipment. That's sort of the perspective that I'm coming from today, because, you know, the bottlers have a slightly different perspective, the haulers have a slightly different perspective, even the consumers have a slightly different perspective. So I'll kind of start here with the consumers that, according to, I took this slide directly from the Glass Packaging Institute. They've done very good research. They're very good to their members, and it's pretty obvious from the information that you can get from the GPI's website that people want glass recycled. That does not seem to be the issue. When you go out and look and see here that 95% of those who live in a community which recycles glass say that glass should continue to be recycled and collected, it kind of goes against the grain of some of the things that we're seeing, for example, out in Houston, where they're taking glass out of the single stream recycling. But we'll dig into a little bit deeper on why some of these things are happening. But again, according to the GPI, it's what people want, and it's not going anywhere anytime soon. We can move on to the next one. What I want to show in this slide here is that in that main green box up there at the top, glass helps communities meet their recycling goals. For example, just one example, in the state of Florida, they have a 75% recycling goal by the year 2020. Well, while glass makes up about 25%, give or take, of single stream, it only makes up about 4 or 5% of the overall waste stream in the state of Florida. Well, if you take that 4 or 5% out of the waste stream right off the bat, and you're already giving them a 75% goal, it makes it harder for them to achieve that value. So putting it in the landfill is not always necessarily the right thing to do, and it's going to make it considerably more challenging for these states that do have recycling goals to meet that goal. So I think one of the first things that we need to do is kind of define what glass is. And I know that sounds like a pretty silly thing to even throw out there, but when you talk to the MRF operators and you mention the word glass, what they envision in their head and what the people that are actually recycling glass or remelting glass or packaging in a glass package, those are two completely different things. So when we talk about glass recycling, most people think, well, of course glass is recyclable. In fact, if you listen to some of the presentations that are done around the country, you'll hear the many wonderful benefits of glass, whether it be that it's infinitely recyclable, longer shelf life, et cetera, et cetera. But when a MRF operator hears the word glass, they kind of hear something and see something completely different. So what I want to do here is start off with how ISRI defines glass. I'm not going to read through all of this, but a couple of the points that I'll make here, Notice words like contaminant-free, and when you read organic matter, it says consists of organic materials that are non-container glass items. For example, paper labels should not exceed 0.2%. And so when the word glass is used, what they are referring to is material that is suitable for the production of glass containers, material that is reasonably contaminant-free, and material that, again, that has less than 0.2% of organic contamination in it. So if we go to the next slide. So when most of us think of glass, this is what we see. But even that, as clean as that is, it's not color sorted. And for that material to be put back into a bottle, it needs to be color sorted. There's the three colors there, the flint, the amber, and the green, and those need to be color sorted. So as clean as that is, it still doesn't meet the definition of a furnace-ready type of material that's ready to go back into a bottle, because one more step has to be done to it. However, when you talk to the MRF and you say glass, this is what they see. I think it's important that we define or use the right terminology. Instead of calling this glass, this really should be referred to as fines, or 2" minus. It's certainly not glass. While that pile right there is probably 85–90% glass by weight, as you can see by volume, you can't even see the glass in it. So to call that glass, or to say is glass recyclable, that conjures an image for the MRF operator that's completely different than what we see from just plain ordinary glass. So this is where the challenge comes. When you go to a MRF operator and say, is your glass recyclable? This is where the rub is all about. So there's the bottom line in all of this is that there's a cost in recycling glass. And just like with any other commodity, there's a cost involved in recycling it. Doesn't matter if it's paper, doesn't matter if it's cardboard, doesn't matter if it's aluminum or tin. There is a cost involved in doing that. And it just so happens that the metrics within glass are considerably more challenging because it's much more difficult to separate out of the waste stream, and there's not as much value for it. So going through this very quickly, to recycle glass, the first thing that has to be done is it has to be collected at the curb. Then it has to be taken to the MRF and processed. Then it has to be cleaned up at the MRF so they can do something with it. Then it has to be transported again. Then it has to be color sorted. And then ultimately, once it's color sorted, it can go directly into the furnace. So if you take all of these things and add them together, it costs money. That entire process costs money. And the real issue that is at hand for these MRFs is who is going to pay for it. The consumer doesn't want to pay for it because it means an increase of their 6-pack of beer. The bottlers don't want to pay for it because it means they have to increase the price of their product. The MRF operators don't want to have to pay for it because it means less profits for them. The municipalities don't want to have to pay for it because it means that they're going to have to increase the cost of collections for their material. Right now, most MRFs are geared toward beneficiation. I refer to this as strategic planning because everybody knows that King Kong in the marketplace in the beneficiation is strategic materials. So most MRFs, because of those metrics, those metrics that are involved in the cost of recycling glass are not very attractive for them right now. They sort of gear their thinking up to prepare their material through collection, processing, cleanup, and transportation to get that material over to strategic materials or beneficiation. Next slide, please. So basically what this is all about is the strategic materials matrix. And if you haven't seen the matrix, it's a pretty good movie. But seriously, the matrix that I'm referring to is the strategic materials matrix, and basically what that's all about is the lower fines you have and the lower NGR or non-glass residue you have, the higher value the material. The more fines you have in it and the more NGR you have in it, the lower the value of the material. So one of the things we're doing at Machinex is trying to help people improve their situation in that matrix. So in other words, we're trying to reduce the amount of fines that they have in their glass, and we're trying to reduce the amount of NGR that they have in their glass. Currently, we have two solutions that are readily available in the marketplace. We've got them out there. They're working. We've been doing these for years. The first one involves a very simple air classification only type of unit. It pretty much just is a vacuum over the stream of fines that are coming out of the MRF, and we're basically sucking off all of the liberated paper, shredded paper, labels, and some of that. What we're not getting out is the remainder of the NGR, which are the rings, the caps, straws, and any other foreign kind of debris that might be in there, from chicken bones to whatever, shoelaces or whatever that happen to be in there. The second step that we currently offer combines air and size classification together. So in addition to extracting a vacuum over that material, we're also running that material through a trommel screen, and it's getting us into multiple different cuts of glass so we can begin to affect the fines portion of that strategic materials matrix. So if you look at the photo in this upcoming slide here, you can see we end up with 3 different cuts of material, and then those materials have different markets. Strategic will take some of it, and then other markets will take the rest. We can go on to the next. And then here's an up-close picture of those. The 3/8" minus is not desirable by strategic because they are going to have a hard time color sorting that in their optical sorting units. But the 3/8 to 2 1/4 is a material that's very desirable for them. The 3/8 minus can be used for another market, such as daily cover, as an example. Next slide. What Machinex has sort of developed with crystalline technologies is we discovered them working with EEQ, which is Eco Enterprises Quebec, up in Quebec, trying to come up with some solutions for glass. And EEQ is very much a extended producer responsibility type organization where they collect money and then they take that money and reinvest it for the purposes of finding markets for glass. EEQ's primary role is doing market research on where that material can be sold, because even if we clean the glass up perfectly, 100% of glass, even if in a perfect world, cannot go back into the remelt industry or the insulation industry, as an example. There have to be other markets because some of the finer material just can't make its way back in there. Crystalline technologies offer some of those solutions. So what we're hoping to see with this sort of relationship with them is the development of some new markets. And these may not be entirely brand new markets, but they're new markets for the MRFs. We'd like to have a sustainable business model to make those glass recycling metrics look more attractive, and therefore try to renew a little bit of interest in the recycling of glass. I won't go into these in detail due to the essence of time, but the long and the short of it is we have developed 3 or 4 sort of standard kits, if you will, or standard packages that can be added onto a MRF. They start at around $300,000 and go up to, gosh, upwards of $1.5 million to close to $2 million, all dependent upon the type of product that you want to create. Obviously, the more money you spend, the more money you can demand for the glass that you're able to make, because you're either able to grind it down to a finer size, or you're able to clean it up to have less contaminant in it, or a combination of both, so you can demand a higher dollar volume for that material. So what our current focus is right now, again, we're looking at the research and development of new markets. We are not in any way, shape, form, or fashion anti-bottle to bottle or anti-remelt, not the case. It just so happens that those markets are pretty challenging for MRFs to meet. So we're trying to help them develop some new ways to look at it. Water filtration media, cement additive, et cetera, et cetera. We're also in the process of developing a financial model right now by installing 5 of these systems around the province of Quebec, so that in the next 6 to 8 months, we will have real-world data and real-world metrics, cost of operation, cost that you sell the material for, and all of that data, so we can make informed decisions for our customers here in the United States. And that is all I have for my presentation today. Thank you very much. I appreciate the attention.
Really terrific. Thank you so much. I appreciate that. We're going to go ahead and launch right into the presentation by our next speaker. Calvin Tigchelaar is with Resource Management Companies. He's the president of RMC, and it's a Midwest-based operator of material recovery facilities. Resource Management is also active in glass beneficiation at its Chicago area location. And I'll turn it over to you now, Cal. Thank you so much.
Okay, thanks, Susie. And I just wanted to check, is the sound coming through okay from my end?
Yeah, it sounds good to me.
Okay. Okay, great. Well, thanks for having us and inviting us to be a part of this webinar. Our company has been in business for 25 years. We operate material recovery facilities in the Midwest, primarily Chicago and in the St. Louis area. And doing that, we come across a lot of mixed broken glass, as we call it. We've got fairly large volume facilities, and when you consider that approximately 15 to 20%, or maybe even higher, as Rusty identified, up to 25% of the single stream material consists of mixed broken glass, it's an item that we need to do something with in a responsible way, or it's going to negatively impact our bottom line. In most areas, the market for this material is in many areas is somewhat limited. Here in Chicago, we've got markets for the material, but there are parts of the country where it's much more problematic. And even in the best of scenarios, and you can go to the next slide, thank you. Mixed broken glass is problematic. Well, why? Starting point would be the low or negative value of this material. Insufficient market capacity, as I mentioned, to absorb it in some areas. You could be out in the middle of the countryside and there is no market for the material in terms of bottle cullet or sandblast media or something like that. The cost of processing mixed broken glass that comes out of a MRF into a product that is useful for someone else is difficult in every sense of the word. When you do process it into a product, as we do, bottle cullet or fiberglass, mixed bottle cullet for fiberglass feedstock, you'll find that the cost inputs are quite a bit higher than the cost inputs that you would use to create a bale of waste paper, but the value of the material is lower. Our experience and what drove us into this was prior to 2005, we did what pretty much everybody else did in our area, which is supply the material to a third-party beneficiator. We never really were able to get that entity to handle the volume that we had, and there was a very large cost to it. We were paying up to $80,000 a month as a tip fee from one of our plants to have the mixed glass taken off of our hands. Even at that, the volume was typically not handled, so we had a large backlog on site. We got into the business in 2005, and it's been fits and starts since then in the last 11 years, but currently we have no reliance on any third party. We do all the processing ourselves. We have a minimal backlog on site. We do sell all the material that we can produce, and we now don't have a cost item on the income statement. We have a revenue item since that time. This slide shows what we make when we're supplying a bottle maker. The pile on the left is Flint or clear glass that goes into making glass jars, bottles, and the slide on the right is amber glass that we use to sell to bottle plants that are making beer bottles and so forth. Additionally, we have to do something in the Chicago area. There's really no market for green, and there's a lot of the material also that, as Rusty identified, is smaller than 3/8. We take that material and we crush it up and ship it via rail cars to companies that manufacture fiberglass insulation, and I'll have more on that later. Next. Also, we do a small amount of production of sandblast media. So in this case, we're putting this material in a 3,000-pound bag, and it's being used by it's being distributed for the use of removing rust and scale from bridges, ship hulls, and other applications like that. I thought it would be useful to rank the end uses because, you know, Rusty mentioned several that they're working on so that at the MRF level, someone could produce ground or crushed material and get it into a road base application or maybe a drainage media application. Ranking these uses, and the way I would rank it, I would say bottle manufacturing from an environmental standpoint is first and foremost because the bottle can be made, it can be recycled, it can be made again with virtually no degradation in quality over and over again. So that's a great one. Fiberglass insulation is also a great one because once it's made into fiberglass, it's probably a one-shot deal. The fiberglass is not currently recyclable, but it'll stand up for a long time when it's put into a residential or commercial application. Drainage media is a little bit lower one on the hierarchy, but it'll be put around a drain pipe and provide good drainage for you know, a long time. Sandblast media, the primary benefit there is it replaces something that is a pollutant, which is sandblast media made from coal slag, and this is much more benign and inert. Aggregate is okay, but it's a very low value one. And alternate daily cover, ADC, I don't really consider that to be a great use for it because it's still ending up in the landfill, you know, so I put that in the last. But those are the way I would rank the end uses for glass. Next. Getting into the MRF and what this stuff looks like, Rusty showed some pictures that I don't disagree with whatsoever, but this is what it looks like coming right out of a MRF system in one of our plants. It's dropped through a 2-inch screen, and it's accompanied by anything else that could fit through that same screen, including organics, bottle caps, so crushed aluminum cans, and various things like that. The next slide shows it coming off of a feeder being metered into our beneficiation plant. And again, as Rusty identifies, probably 80–85% glass, but there's a lot of trash with it, and all of that has to come out. The aluminum has to be recovered, the steel lids have to be recovered, the trash has to be thrown away before you can really attempt to optically sort it. This is the trash that's coming out of that stream that you just saw, and of course the video will be jumpy coming across the phone lines, but the conveyors actually run smoother than that. But that amount of trash came off of that feeder that you saw there. Next. We also have to engage in drying processes. So in this case, you're seeing the material on again, it's not playing very well, but it's on a shaker screen that has dried the paper. The dryer has dried the paper, and we're going to try to vacuum that from the glass so that the optical system can be busy with sorting glass and not with, and that's the paper that's getting vacuumed from that stream that you just saw. So the optical system can be busy sorting glass, not firing at contamination. But all of this is to say that, you know, there's a lot of contamination in the glass. This is what it looks like when we're ready to sort it. And you saw it coming in on the feeder screen, and, you know, this is actually worthwhile now. A lot of the trash is out of it. There's a little bit left, but we'll be able to extract the flint and the amber cullet from this. Again, this is the same stream now. Most of the trash is gone, and we're feeding it into an optical sorting device, a machine that can eject as many as 60,000 pieces per minute, 1,000 pieces per second of glass sized from 3/8 to 3/4 of an inch, and recognize the difference between clear and amber and green and contamination. Typical module. This one's supplied by the Binder Company of Austria, a lot of great technology coming out of Europe. The turquoise and blue machine is an optical sorter, and, you know, it's taken out all the flint, so now what you see is heavy and amber on the next machine. The next machine will take the amber out, and that's kind of the optical sorting process. Next. when we're finished with it, hopefully we've got material like this that has a value of maybe $80 a ton for the flint, maybe $60 a ton for the amber in our region on a picked up basis. But as you can see, when you talk about corrugated cardboard at $130 and $140 a ton, where all it has to be is conveyed into a bale or pressed into a bale, there's a lot of cost inputs here to get it to this point. In our case, we've got the volume to justify it, but not everybody does, and not everybody's going to want to put that kind of level of technology in. So we're at the other end of the process from making it into just drainage media or something like that. The challenges here with this in a MRF setting, and we're one of the very few companies that's actually doing it in a MRF setting, it's very capital intensive. This equipment costs a lot of money, so you need volume to justify that. It costs a lot to maintain this equipment because this glass is extremely abrasive. It's used for sandblasting for that reason, but it destroys metal surfaces, and you have to do preventative maintenance constantly on it. And then once you've created those piles of glass that you saw in the previous slide, the specification to get a market to accept it is very, very stringent. I mean, ceramics cannot be there. Moisture's got to be controlled. The trash level has to be controlled, and you can make all this stuff unless you can sell it. You haven't really accomplished anything. And you can go to the next one and then skip this one. We'll go to the next one after this. But a lot of maintenance on this equipment. This is just showing an entire room that's got air compressors and filters, air cleaners, because you've got to feed a lot of compressed air to these machines to keep them happy. So that's a big utility cost. We've got to dry the material in the winter, especially, and there's gas involved. So it's an expensive process. So going forward, you'll find out why we think we should still be doing it. The other part of this is we have to do something with the green glass. As I said, there's no market in this area, Midwest really, and the finer material, and that's about 60% of the stream is going to be smaller than 3/8 or green. It's got to be dried, crushed, and screened and sold to somebody in our model. And when you're finished, the organic content, which you need to test in a lab type environment, cannot exceed 1/5%. This is just showing what the material looks like once it's come through a crusher and is approaching the screening process. So we've tried to break it down so it'll pass we'll call it a 12 mesh or a 7/100 inch screen. That's what 12 mesh is. And of course, some of it doesn't and has to be reprocessed. But once we've done that and we've achieved the organic contaminant level that we need to achieve, and we've achieved the moisture level that we need to achieve, we now have a material that looks like this. This is the final product coming out of our green and our fines that will be loaded in a rail car and sent to an insulation manufacturer. And very, very stringent specifications for this one too. But this is the biggest part. Again, that's the slide of rail cars. We ship this to distant markets because there aren't many in this area. Challenges with this one: well, it doesn't cost you that much to buy the equipment to do the crushing and screening, but it costs you an awful lot to modify it to make it suitable for this application, because it'll just get torn apart by glass if you don't take preventative measures and hard face weld everything. But a lot of maintenance going forward. So that's that. Now, getting into the philosophical side of it, or the business side of it here, is it worth recycling? I'd like to look at it in this conversation primarily from an environmental and cost viewpoint. And when you look at the people and the benefits that are achieved by the companies that we sell the material to, and that's really where the environment gets impacted positively. If someone is operating a bottle plant or a fiberglass insulation manufacturing facility, and they start incorporating, they go from 100% virgin to some percent of recycled cullet, and if they go to 10%, they can save 3% on their energy bill. If they go to 100%, they can save 30% of their energy bill. That's a good number. I mean, 30% of an energy bill for a bottle manufacturer, even 20 or even 15, is a big number. It could be in the millions of dollars per month. But the bigger thing that's occurring here in terms of environmental benefit is there's a reduction in carbon emissions, because some of these raw materials that are used to create virgin glass, the virgin materials, have carbon content. And when they're heated up to create the fusion process that melts everything and makes it one mass, that carbon has to be released, and is released in the form of CO2. So you're getting none of that when you're using mixed broken glass, because that already occurred in the original glass making process. When you recycle glass, the glass that we produce in our operations, you're basically just reheating it. Also, in terms of cost, plants that are using recycled cullet have less fusion loss. In other words, if you put 100 tons of virgin raw material into a furnace, my understanding is that 80 to 90% of that could become product, but 10 to 20% of it is going to be lost when this material shrinks because of the loss of carbon and other things. When you put 100 tons of mixed or bottle cullet that we supply, or SMI supplies, or someone else supplies into a furnace, it's almost 100% recoverable. So you have 100 tons of product at the back end, and you have virtually no CO2 generated. So those are the big things. In terms of why, I also think it's great for recycling. There's no degradation. Glass can be recycled over and over and over again, as steel can. Paper and plastic, no. Paper, as you recycle it, the fibers get shorter and shorter. Ultimately, it disappears into the sludge at the paper mill. That doesn't occur with glass. It can be done indefinitely. There's a massive quantity of this material out there and available, and there's much, much more market capacity that needs to be satisfied before we start. Should it be removed from programs because it tends to cross-contaminate other items? I mean, does it get into the waste paper? When you ship a bale of waste paper, is there broken glass in it coming out of your MRF? In the PET bottles or milk jugs? Well, that's a function of single stream. You know, all these things are being mixed together, and glass does have the potential to contaminate other items, but milk jugs and aluminum cans contaminate waste paper, and waste paper contaminates PET if your system is not set up right. So I really don't blame glass for that. I think it's very easy to screen it out. You might have to screen more than once. We have multiple screening steps in our operation to try to capture all of the glass. We don't want it in the product, we don't want it in the baler, and our customers don't want it. So I really don't think that's a justifiable criticism of glass. I think it's fairly simple, and it can be done. Next. You know, the whole initiative here with the Glass Recycling Coalition, and what we're trying to message, that I think we're trying to get out there, is yes, glass should continue to be included in single stream collection programs. You know, single stream is challenging and it's tough, and I'm not so sure that we all should have gone to it years ago, but like it, don't like it, it's out there, it's the system of choice. I think Rusty showed a slide that 80% of the country is utilizing single stream for its collection. So it's there whether we like it or not. It's probably going to be the best way to capture this bottle glass. If you keep it out of those programs, it's likely the bulk of it's going to end up in the landfill, because people are not going to want to go to the trouble of taking those glass bottles to some depot or putting them in their car and driving any length. It'll just get thrown away. If you look at states where deposit legislation is in place, you'll still find a lot of glass in the single stream, because it's coming in wine bottles, it's coming through food jars. It's not all carbonated beverage containers that are being returned. There's still a lot of glass around there. And I think that really what has to happen here is the decision makers that are running the municipal collection programs, they need to recognize that this stuff is challenging, yes, it's low value, yes, but the environmental benefit of it when it's recycled, that should be given very high marks, and it should be approached from that perspective. You know, this is kind of a wrap up. How do we view it? And again, we're one of the few MRF operators, I believe, in the country that actually got into this business, and we more or less got forced into it. But after we got forced into it, we started to like it, and we started to consider it to be a core business. So, you know, we're at the other end of the spectrum, again, from someone that's just looking to crush this stuff up and dump it in a landfill or for a road base, or, you know, a low-end application. We went the other way, and what our perspective on it is this: we used to have a very large cost getting our material handled and taken away. That's gone to zero now. It used to be $80,000 a month at the highest. So that's given us the production of bottle cullet, selling to bottle makers, and the sand that we sell to fiberglass insulation manufacturers has given us pretty significant revenue for an item that used to be a cost. However, when we're running these operations, we generate a fair amount of trash. There's a lot of trash mixed in with the 3-mix glass, so our disposal costs coming out of our MRF operation as it pertains to the 3-mix processing is significantly increased. We've got to do a lot of maintenance now that we didn't have to do in the past because we used to just take a loader, scoop the stuff up, put it in a truck, and send it away. Now we've got conveyors and machines and feeders and cleaning devices and cyclones, so we've got a lot more maintenance than we used to have. In terms of labor, we've got a nominal increase there because most of these operations are automated, but there is some increase. How did the return on capital? Well, we invested a lot of money, but the return is adequate. We consider that to be a good operation for us, a good core business. We improved our net income by doing this, and instead of desperately walking around a 15,000-ton pile of glass that was growing by the day and not knowing what we were going to do with it, with a sense of futility, well, that's gone. We view it as an opportunity in a business now, and our current challenge is really, we compete with other companies. We compete with companies like SMI who are in the business in our area, and we're all looking for good quality 3-mix glass. To the extent that we can find a supplier that is willing to invest in the type of equipment that Rusty's company supplies, and I've seen the equipment in operation, it can do an excellent job of creating really great feedstock that a beneficiator like ours can use. To the extent that we can find suppliers like that, it's great. I think what, tying Rusty's presentation and mine together a little bit, I think that there's a great future for MRFs in creating their own product of the type that Rusty outlined in the end of his presentation, which was road base and things like that. And then there are some MRF operations, or maybe a collaboration between several MRFs that can do what we did, which is to go a little further with it and supply bottle cullet and fiberglass insulation feedstock. But the big thing is keep the stuff coming, keep it in the programs, and keep finding creative uses for it, because it's a really great item to be recycling. And thank you very much for your attention. And that's it for me, Susie.
All right, Cal, really super. And I know we've got some questions from the group. And I want to just let everybody know that if we don't get a chance to answer your question, we're going to work on making sure you get a follow-up email with a specific response. I would like to just use my prerogative here as the moderator, just some salient points I heard today that I think is really great, because I don't know about the rest of the listeners, but my impression is that glass has been in the doldrums for a while, and so I'm hearing some real optimism and encouragement for us at the community level to keep getting the glass to you, to continue to work on contamination issues, of course, but perhaps not be quite as intimidated by them as we've been led to believe for the last few years. I think a lot of people just think it's too hard to get glass clean enough to the end markets. So we're talking about, glass has got a modest value, and there's just financial metrics of processing it that both of you referred to. But I think it's exciting to hear about new cleaning technologies like the ones that Rusty's talking about, and to then hear about new markets that are available. I think the really, really important message about energy savings and environmental kind of benefits from glass recycling need to be something that we communicate to our communities. It seems like there's some myths that need to be debunked a little bit about, you mentioned, Cal, about the contamination in the single stream, and I also think it's interesting to find out that deposit states are still having glass in the single stream. I didn't really realize that. But finally, just again, the sort of in summary, the challenge for you guys is finding enough good glass to really be able to keep your plants running, and getting more procurement is your issue, not as much as contamination. So with that, do you guys want to add any notes for sort of like from the geographic level? I mean, we've got people from all over the country listening in. Can you talk a little bit about how important it is for us to know where our glass is going and what it's going to be used for, so that we can kind of, again, tailor our messages to the public?
Do you want to go ahead, Rusty, with that one?
I was actually going to hand that one to you.
Yeah, for instance, Cal, for instance, with fiberglass, a lot of us understand the bottle-to-bottle issue, but we're not as familiar with the specs are for fiberglass manufacturers.
Yeah, well, I mean, it's got to go through. It's a tough process. Okay, we're looking at a stream of material when it comes out of a MRF that is probably 20% contamination, organic contamination, paper, and all the tramp material that's with it. And by the time it leaves our facility and heads towards the fiberglass manufacturer, it's got to be 1/5 of 1%. So that's a specialized operation. But you know, we can make that happen. We're doing it every day. But when we're procuring mixed broken glass, you know, Rusty had a couple great slides of what a MRF operator thinks mixed broken glass is, and it is. That's the way it comes out. If that material is picked up in that form and taken to someone like us or someone like SMI, really the carbon footprint of that whole operation is not good, because now what you've done is you've got trash that should have been left at the MRF, all the bottle caps and the little pieces of shredded paper and plastic that are in there, and you're transporting it somewhere else, where that entity that's taking that material is going to have a lot of inputs to get that garbage out of there. So the thing to do is to have that cleaned up at the MRF level. And Rusty showed equipment there that can get it very clean. Instead of being 20% trash being driven down the road, it might be 5%. Okay, that's very doable with a modest investment of maybe $500,000. And I think, like in our case, we're willing to say to a supplier of that type of material, hey, we can make a financial benefit to you by cleaning it up like that. Because really the place to do it is not at the beneficiation plant of SMI or us or someone else, but at the MRF while it's on the fly. And that's the way these systems should be designed, the processing system. I don't know if that really answers what you asked, Susie, but that whoever's doing your processing for you, needs to be encouraged to attack that glass stream at the MRF, not take whatever garbage he can include with that and send it off to the next, because all that does is negatively affect the economics of the whole system and increase the carbon footprint.
Right. Right. Some of the questions that are coming in have to do with the different colors of glass that are coming into, in our single stream program. So you have optical sorting equipment that can separate that out. But can you talk a little bit about why they have to be segregated, the colors segregated, Flint and amber and green? And
there's a simple answer. The Flint glass, the clear glass, gets made into clear bottles, and you can't make a clear bottle out of amber or green glass. And the same for the amber. The amber has to be made. The brown beer bottles have to be made from amber glass. So you can't melt it and then change the color. It's got to, the color is through and through the glass. So that has to be sorted before it goes in the furnace. And that's what's happening at virtually every glass beneficiation operation in the country. The problem we run into is there's no market for green in the Midwest. We got to ship it to Oklahoma if we want to sell green glass, and that's not feasible. So when you say
that mostly becomes then an abrasive or a sandblasting kind of material?
A fiberglass insulation. I mean that's there's no color sorting there. So we're crushing any color glass to create the feedstock for fiberglass insulation or sandblast media, right? But for bottles, specifically for making new bottles, you have to use the same color that, clear for clear bottles and amber for amber bottles, green for green bottles.
Yeah, and that's to piggyback on that again. not to say that we're against bottle to bottle. It's absolutely, like Cal said, it's one of the best uses of the material, but some of these other markets do make it a little bit easier to achieve their specification because the material does not have to be color sorted, and that does remove one of the steps from the process.
And Rusty, you said your pilot projects are up in Quebec, and you should be having some data coming out pretty soon using the crystalline system.
Yeah, so there are actually 5 systems being installed over the next couple of months. I would say by early to mid-summer, we should have really good data on, the cost to run the equipment, what types of products can be made out of the systems, what types of markets those customers up there are selling that material into, and most importantly, how much they're able to get for that material. Because at the end of the day, it really does boil down to how much you can get for it. And what Cal's company is doing there with his beneficiation process is trying to increase the value of that material. And if his input dollars, which are initial capital investment and operating costs, which include maintenance and electrical and stuff like that, are lower than what he can sell the material for by ton, et cetera, if all that math works out, then obviously Cal's going to invest money in that kind of equipment.
And I guess that's what it comes down to, you guys. There's several questions from our listeners about financing and return on investment and financing this kind of thing. Do you have any comments about that? And I think we're going to have to sort of conclude with this the discussion, because I know Marissa has some concluding comments. But any ideas about how to get this financing issue resolved at the local level?
Yeah, I'll definitely defer to Cal on that one because his company's been involved in it for many years. He knows exactly what the economics look like. I think he's definitely the more qualified person there.
Well, I mean, it's just like anything else in the MRF operation. If you buy a baler and a conveyor to feed a baler, and you feed loose corrugated cardboard in there, when the product comes out, it's got a value, and there's a cost that it took to get it to that point, the depreciation on the baler, the maintenance. So it's the same thing. It's just that this is a little more complex. We are making this work on the value of the material that we're selling. So, are you going to be able to pay a lot of money for mixed broken glass coming out of a MRF? No, you never will, because it's, the material that we are competing with when we sell our product is virgin material, which is very modestly priced. You're talking about silica sand, soda ash, limestone, feldspar, stuff like that. And so you're not going to, but you can probably get the raw material for $0 or less, depending how dirty it is, or you might pay a little more for it. But it's a modest cost for the raw material. And now, what's it cost you to run the process? Just like making the bale of cardboard. So we're doing this not with any subsidy or anything else. We're just doing it with the starting point being MRF glass at something like 0. And it works for us, but you can't do it with 1,000 tons a month or 2,000. You've got to have a lot more volume than that.
Okay, so volume is really important. Yeah. Okay, well, I'm going to need to, I think Marissa's going to cut in here any minute now, and I want to thank you guys. This has been so interesting. Marissa, I'm going to let you wrap up. Thank you again, Cal and Rusty.
You're welcome.
Sure. I wanted to definitely give a big thank you to our speakers, Rusty Angel with Machinex, Cal Tigchelaar with RMC for participating in the webinar, and certainly a big thank you to Susie Gordon with the City of Fort Collins. You all have been great. This is such a great opportunity to expand our knowledge of glass recycling processing, which in the public sector we don't always get to see through those eyes. But through the Glass Recycling Coalition, we want to give more opportunities like this. So if you are interested in to continue to be in touch with the Glass Recycling Coalition, we encourage you to go to our website, glassrecycles.org. Send us an email if we can help out. And also, you will all be receiving a survey in your inbox. Tell us what you thought of the webinar. Tell us what other webinars you want to see in the future. We're here to provide resources and to make this work, and we can't do it without you. So thank you so much for taking the time to be Glass champions on this call today, and we hope that you will stay engaged in the future. Thank you all, and have a great evening.
or afternoon, early evening.